Good morning. Today we are going to look at a use of exponential decay rates that's very real and very practical. It's in the world of medicine, and we have all been the beneficiaries of this when we have taken medicine. But who actually decides how much medicine to take and how much medicine to put in each pill that you take and things like that? So that's what we're looking at today. So here's our situation. You are a scientist working for a pharmaceutical lab and have developed a new drug. According to your research, 30% of the drug is eliminated from the bloodstream every 6 hours. The patient needs to have at least 500 milligrams of the drug in the bloodstream at all times, but the total amount should never exceed 2,500 milligrams. The drug should be taken for no more than 4 days. You need to design a pill size and a dosing schedule that will be convenient and easy to manage for patients while meeting the requirements above. So I've given you some guidance here. Start by listing the information you will need to solve the problem and use your own paper to complete the task. Be sure to write down all your data and assumptions. Then use graphs, numbers, words, or algebra to explain how you reached your conclusion. So we won't worry about the extra time remains right now. So the situation is we need to figure out how to manufacture this drug. So what pill size, that's right here. And then we also need to decide what the dosing schedule will be. So think back to times that you have taken medicine. Now the pill size, that is dependent on what type of medicine you need and what would be the therapeutic dose for whatever medicine that is. But think about the dosing schedules. That's the part I really want to focus on. So what are some things that you've taken before? Like I know that I've had things that I take once a day. I've had things that I take twice a day, 4 times a day is possible. I know that my kids have had things where they take 2 pills on the first day and then maybe 1 each day following, or they'll do 2 doses on the first day and then 1 dose after that each day. So there are different situations that you can use for dosing schedules. You don't want to make it super complicated. You don't want to be like, okay, on day 1 at 7:03 you take 5 pills, and then at 8:42 p.m. that day you take 3.5 pills. Like, you don't want to make it awkward for people. You want something that is easy to remember and easy to do. So that is what I want you to keep in mind for that. So I'm going to show you how we can use Desmos to get an idea of what's going on here. So first of all, we have danger zones. We need to keep this medicine in the person's bloodstream above 500 milligrams so that it's doing some good, but we need to keep it below 2,500 milligrams because that would be the danger level. So I want to see that window on my screen. So I'm going to go over to this wrench here. Instead of just using my hand to adjust the size, I'm going to actually tell it what to do. So I want my Y values to go, I'm going to show 400 to 2,600 as my viewing window. So a little bit outside of the restrictions that I'm given. Now the X value here is going to be about time. Now how many days are we supposed to take this medicine? Read back through that. It said we need to be on it for 4 days. So let me go back to that for a second. We need to take this for no more than 4 days. Now the medicine is something that decreases 30% every 6 hours. So instead of monitoring this by the day or by the hour, I am going to choose to think about it in 6-hour chunks, okay? So how many 6-hour chunks would there be in a day? Well, that would be 4. And I need to take this medicine for how long? For 4 days? Okay, so that means if there's 4 chunks per day, 4 6-hour chunks, and I need to be on it for 4 days, there's going to be 16 decay windows, decay chunks, if you want to think about it like that. So I am going to choose on Desmos to make my time go from 0 to, Well, it would be 16 because 4 6-hour chunks and 4 days. I'm going to make it go to 18 just so I can see a little beyond that, so it's not right pushed to the edge. So if I click there, so that's my viewing window. So I want to keep the medicine above 500. So I need my medicine, my Y's, to be greater than 500. So what I'm going to do here is I'm going to shade under 500 as a danger zone, okay? I don't want it to be green, I don't think. Let's see, what color should we make that? Oh, let's see, how do I change colors again? Okay, we're just going to let it green. Okay, so I don't want it to go down in the green zone there because that would be bad. That would be not enough medicine to do any good. I also don't want it to go above 2,500. So I'm going to say Y above 2,500 milligrams would also be bad. So see that purple region up there? I don't want it to go that high because that'd be bad. So I gotta keep it in this sweet zone here in the middle. Okay, so that's my target. And let's see. So then let me write down over here what our formula is that's going to come into play. So we are having medicine that decays. So we would be looking at something like Y equals A times 1 minus R to the T. But for T here, I'm thinking in 6-hour chunks. 6-hour. Ooh, that's sloppy. Six-hour chunks. Sorry, that's sloppy. So now what is the decay rate that's happening here? How fast did it say the medicine decayed? Let's look back at that for a minute. It says, according to your research, 30% of the drug is eliminated every 6 hours. Okay, so my rate here would be a 30%. Only in order to put it in, I'm going to need to put the decimal form of that. So that would be a 0.3. So in parentheses there, I have 1 minus 0.3. So that would be a 0.7. So I'm going to have a 0.7 to the T power. Now A, what does A stand for in this situation? That's the initial amount. So that's how much medicine I'm going to take when I first take a pill here. So we get to decide this. We get to decide how big the pills are going to be. So I'm just going to try something and see how it goes. So let's say I'm going to try making pills that are, well, let's just go the full amount. Let's go 2,500 milligrams. And see if we could just take that once a day. That'd be nice and easy. One time per day. So let's see how this goes. If I'm going to take 2,500 milligrams one time per day, I'm going to go over here to Desmos. Let's graph this. Oops. So Y equals, let's go ahead and take 2,500 milligrams as our initial dose. In parentheses, I'm going to put my 0.7 to the x power and see what that would look like if I graph that. So, alright, so I see my declining medicine here. So I was taking 2,500 milligrams. That puts me at the very tip top when I first take it, but that's okay because it said does not exceed, and I'm not going to exceed it. I'm just going to be right there. And then it's going to decline. Now, if I'm going to take this once a day, that would mean my next dose would come at the 4 on my x-axis. Why? Why would that be? So remember how big of chunks I'm looking at here for time? Yeah, these were 6-hour increments is how fast this decays. They're getting a 30% decay rate every 6 hours. So that means 4 time frames later would be 24 hours. So if the next day I've taken the 2,500 milligrams, 24 hours later, I still have 600 milligrams, 600.25 milligrams of this in my bloodstream. So if I go ahead and take a 2,500 milligram dose right then, I've already got 600. Oops, let me write. Let's see, 600.25 in my bloodstream. And if I take another pill that's 2,500 milligrams, well, that's going to be bad right there, isn't it? That's going to put me over the threshold of how much is safe. So that's too much. I can't do that. Okay, so that dosing schedule or pill amount is not going to work. So let's try something else. So let's see, what else could I try here? What if instead of a 2,500 milligram pill, what if I make that a 1,500 milligram pill? Okay, so we're going to try 1,500 milligrams. And maybe I could take that, I don't know, let's try taking that twice a day. Okay, so I'm going to make a table so I can keep track of how much medicine is in my bloodstream. Okay, so time, and we're thinking in 6 hours. So 6-hour chunks is what I'm going here. How much medicine we would have. So let's see. So at time 0, I'm going to go ahead and take 1,500 milligrams. Okay, so that's what you see on the graph right now. So if I'm going to take this medicine, I'm going to try out twice a day. So that would be every 12 hours, twice a day. So that means my next dose would come where my time, my x value, would be 2. So let's see, I'm thinking that's about here. Oh wait, where is it? Here we go. Okay, so 2 time periods later, in other words, 12 hours later, I would have 735 milligrams in my bloodstream. Okay, so 2 time chunks later, I'm at 735. So it's time to take another pill. So I'm going to take another 1,500. So if I have 735 in my bloodstream and I take another 1,500 milligrams, I would be at 2235. Is that safe? Can I do that? Yeah, that's okay. That's below my threshold. Okay, so now I'm going to let that decay. Okay, so here's what I'm going to do on the graph to keep track of this. So this first dose gets me from the beginning to the 2-hour mark. So I'm going to limit the domain here from 0 to 2. So remember how to limit the domain? We use the fancy brackets, and we say we want this to go from 0 to 2. Okay, now the next dose is going to happen. So now my beginning amount is now 2235, because that's how much I have left in the bloodstream, plus I just took another pill. The decay rate is still going to be the 0.7 to the x. Now, for this x, I want to shift this graph over 2 time chunks, okay, because I am now 2 hours into my dosage. So if I look at this, that shifts the graph over. However, I need to limit the domain on this one too, because this dose is not going to kick in until the 2-hour mark. So 2 is less than x is less than 4 is when I'm thinking this should end. Actually, I'm going to wait on the ending point for now. So if I didn't put an ending point on, you would see the exponential decay graph on here. So let's see. The next dose, according to my current hypothesis, that I'm going to dose 1,500 milligrams twice a day, that would happen, so 4 time frames have passed, so, because that would be another 12 hours is what I'm doing there. So let's see, where would we be at? So if I look at the red curve here, 4 hours would happen about here. So there's then 95, 15. So at the, that'd be one day, because 6-hour chunks, 4 6-hour chunks would make one day. So I've been on the medicine one day. I have 1,095, 15. Okay, so let me write that down. 1,095.15. And it's time for my next pill. So I'm going to take 1,500 milligrams equals, oh no, that's going to be too much. That's going to put me over the threshold. Okay, so this dosing schedule isn't going to work either because I would exceed my dose as soon as I take that next pill. So you can adjust a couple of things here. This is where I'm going to turn it over to you. You can make it a smaller size pill if you want. You could try doing, I don't know, like 800 milligram pills. Maybe give them 2 pills on the first dose and then 1 pill each dose after that. And you could try twice a day. You could try once a day, see if that would maybe get you through. Different things like that. So that's what I want you to do today. So if you would get a job at Lilly, for example, Lilly's a huge employer in Indiana. And this is what they do to figure out how to effectively keep people in the therapeutic dose without making it overly complicated on the patients. Because the more complicated the directions are for how to dose medicine, the more likely it is you're going to have somebody mess it up, and we don't want that. So anyway, let me know if you need help, and remember that Jesus loves you, and so do I, so do your math.